Hi guys, so welcome back to my YouTube channel. My name is Karabo Setsole, and in today's video I just want us to look at integration, and this video is just going to be a very short video that looks at the first few rules of integration, right? But before we get to the rules, let's understand what integration is, right? So when you started calculus, you should have been introduced to what we call differentiation. So with differentiation, we are finding the first derivative of a function. So we would be given sorry, let me just use a different color. So we would be given a function f of x, right? And I like to refer to this as an original function, right? And what you would do is that you would find the rates of change of this function, right? And you would denote that as I call it f1 of x, right? So this is the rates of change of the original function, rates of change. So with integration, what we are trying to do is to move from the f of x function, from this function, back to the original function, right? So we are basically undoing the differentiation that we did, right? And that's what integration is all about. And there are certain rules that you now need to follow in order to reverse the differentiation that you did, right? So we have two types of integration. We have indefinite integration, definite integration. So with indefinite integration, we are saying that you are not moving from one point to another. So you're not going to evaluate the function that you just integrated. You are just integrating whatever f1 function that you are given, right? And you are not evaluating that function. But with definite integration, we are saying you are moving from one point to another and you are evaluating the function. And when I say evaluating the function, I mean if you are moving from 1.1 to 2. So this is how definite integration is going to play out, right? So if you are moving from one point to another and you're integrating the function, then you're going to have to evaluate the function, meaning when you have integrated the function, you're now going to say f2, right? Evaluate the function, whatever function you're given, substitute 2 minus f1, right? This is what I mean by evaluate the function, right? But we're not there. That's not what our focus is on today. So let's look at the rules and do an example, right? So the first rule says when you have a function raised to a certain power, right, and you are integrating that with respect to x. So the dx part, the dx part tells you what you are differentiating with respect to. So if it said du, right, it means you are integrating with respect to u, right? If it said dv, you are integrating with respect to v, right? In our case, we are using dx, meaning we are integrating with respect to x. This is very important. These are the basics that you need to understand. Don't cram the content. Really understand what each variable, what each symbol means, because when you get to integration by parts, and if you don't understand the basics, then you're going to have an issue, right? Okay, so the rule says take the function, add 1 to its power, divide by whatever that power now is, right? But this is to exception with functions that have x to the power of -1, not any other number, but -1, right? So this is to exception with any functions, right, that are to the power of -1. That one has its own function, right? So if you remember from differentiation, we said that if you had a function f of x is equal to ln x, all right, and you wanted to find f1 of x, remember what you would do. The rule said take g1 of x, divide by the function itself, right? So you take the derivative of the function. Why am I using g of x? But anyways, you take the derivative of the function, right? And our function was ln x. The derivative, okay, so to find like the derivative of ln x, use this rule g1 of x over g of x. And then you will have 1, because when you differentiate x, you get 1, override the function as it is. And the function that we are talking about is the x function, the one inside of the ln, right? So you're going to differentiate the x and you get a 1 over the function itself, so 1 over x. And if you remember from grade 12, this is the same as saying x to the power of negative 1. So what we are saying with our rule under integration is that if I want to move from x to the power of negative 1 back to the original function, right? What was the original function? Ln x, right? So meaning if you're integrating x to the power of negative 1 dx, it's going to be finding the original function, and the original function was ln x plus c, right? So that's the second rule. The third rule says if you're integrating e to the power of k being a constant x, right? Not e to the power of x to the power of 2, not something like e to the power of x to the power of 2. No, not something like that. Something like when you have e to the power of 2x, when your x has a coefficient constant. So that's when you use this rule, when your x has its coefficient as a constant, right? Not when anything else happens. You'll see that as we continue, we're going to do integration by parts. And when that happens, then you're going to, when you have, for instance, something like this, you're going to have to use another rule of integration, right? So you're not going to use the very same rule that we are using right here. So what the rule says is that take e to the power, take the function as it is and divide by k. So divide by the constant. And in all of these rules, don't forget to add plus c. So you just write plus c to show the marker that it is possible that you had a constant. So let's make an example. Let's say you have a function f of x is equal to x squared plus 7, right? If you had to find f1 of this function, it would be 2x, right? Plus 0, because you are differentiating a function, which would be, you are differentiating a constant 7, which would be equal to 2x, right? Take another function g of x, and say you are differentiating x to the power of 2 plus 3 this time around, right? So you had a 7, now you have a 3. This is going to be 2x plus 0, right? Which is going to give you 2x. So do you see that when you are differentiating two different functions, right? You have f of x, which is x squared plus 7, and g of x, which is x squared plus 3. You are differentiating two different functions. However, they give you the same answer, right? And why is that? It is because when we differentiate a constant, any constant, could be a million, could be 1 billion, could be 1, could be 7, the answer is still going to be 0, right? So to take this into account, because what we are saying is that we are moving from g1 of x this time around to g of x. So you're moving from the derivative function to the original function. And remember that there's a constant, hence you have to add the constant parts, right? You don't know what the constant is going to be, so you just add c, right? So in order to be able to solve for what c is, we need to be given more information about the function that we are dealing with, right? So let's get rid of this because I'm done explaining that. And then what I want us to now cover is an example, right, of how all of this works. So I have 4 examples, and they increase in terms of how challenging they are. Excuse me, let me just finish erasing these, right? So okay, let's just use a different color because we're answering now. So let us say you are given a function. So let's start with number 1. So at number 1, we have to integrate the function 6x to the power of 3, right? So you have to integrate 6x to the power of 3 with respect to dx, right? So there's a rule in integration that I didn't write here, but it says when you have a constant multiplying a variable that you are integrating with respect to, you can take out the constant, right? So you're gonna write 6, the integral sign, and then you have x to the power of 3 dx. You can't take out a variable to the other side. You can only take out a constant that is a coefficient of the variable you are working with. So you can't have something like integrate 6x to the power of 3 plus 6 and then take out the 6 plus 6 and have something like this. All right, this is wrong. It is when the constant is a coefficient of the x that you are allowed to take it to the other side, right? It is when the constant is a coefficient of x that you are allowed to take the constant to the other side, right? Okay, let's continue. So you can't take a plus 6, right, and take it to the other side. You can't do that. So because the 6 is a coefficient of x squared, you take the 6 to the other side and you're left with x to the power of 3 dx. Now I'm going to apply the first rule of differentiation, which says if you have x to the power of n, write the function as it is, add 1 to the power, right? So it's going to be 6. And now that I'm integrating, I let go of the integral sign, write the function as it is, write the power, add 1 to the power, and now divide by what the power is, right? And the power is 4. And this is going to give you 6 over 4, which is 3 over 2 x to the power of 4. Not forgetting our c, right? So that is how you would do the first working. And then the second working says integrate, right? So it's s, which is the integral sign, to the power of 4x. I have a constant 4, right? And that sounds like the third rule, right? So it says write the function as it is and divide by k, right? So I'm integrating, so I let go of the integral sign. I write e to the power of 4x divided by the k. The k is the coefficient of the x, the constant, right? And then I divide by 4, right? And this can also be written as 1 over 4 e to the power of 4x, right? Okay, those are the first few examples. Let's get to the third one. The third one says integrate 2 over the square root of x with respect to dx, right? So I should have written dx here. So what you have to do first of all is to write this in a manner that you would understand. So I would write 2 and take the x to my numerator. So I'd put it as x to the power of negative 1 over 2 dx, right? One of the rules of integration say that if you have a coefficient being a constant, coefficient of x being a constant, you can take the coefficient, right, to the other side of the integral sign. I don't know what that is, but okay. So take the 2, write the integral sign. Now you only have x to the power of negative 1 over 2 left, right? And then what you have to do is to use the first rule. What did the first rule say? It said take the 2, right? And then write the function as it is, add 1 to the function, divide by whatever the power now is, right? So negative 1 over 2 plus 1 gives me 1 over 2. When you simplify this, you should get 4 x to the power of 1 over 2, right? Which will give you 4 to the square root of x plus my c. Right, and then the last example that we have for the day, number 4, right? Let's just erase this and write our number 4 right here. Okay. Number 4, which is an interesting one, says integrate 1, 3 to the power of x dx. So what we are used to is something like e integrates e to the power of kx, right? And if you remember from last year, in grade 12, if you had a function, right, and let's say you're trying to simplify a certain function and the function looked a bit complicated, you could introduce the variable k, right? So you could make k equal the complicated part, right? So what seems scary in my function is the 1, 3, right? So I can make that equal to k. but I want to use a certain rule of integration, right? So the e to the power of kx, because that is what has a k, right? So what I will do is that I will equate the 1 comma 3 to e to the power of k, right? So remember, you can introduce anything as long as it makes sense. So I'm saying that wherever there is 1 comma 3, I'm going to put e to the power of k. That is allowed because you're saying wherever there is 1 over 3, wherever there is this, I'm going to equate it to e to the power of k. And at the end of the day, wherever there is e to the power of k, I am going to bring back the 1 comma 3, right? So let's do that. So I'm gonna say wherever there is 1 over 3, I'm gonna put e to the power of k. So I put e to the power of k, and then I put the x exactly as it is, dx, right? Now I have e to the power of kx. What does the rule say? The rule says write the function as it is and divide by k, all right? So I'm gonna say e to the power of kx over k, right? Plus c. Okay, I need my answer in terms of what I originally had. I said that wherever there is e to the power of k, I'm going to put 1 comma 3. So I put 1 comma 3, right, where there is e to the power of k. And then I just write the x over what is my k. I now need to solve this function and find what my k would be. So I have 1 comma 3 is equal to e to the power of k. All right. And then if I had to find k, I need to introduce ln. Ln is log e. So I would have log e 1 comma 3 is equal to log e to the power of k, right? So that is how you get rid of an e. You introduce a log e, also called a ln. So if you check, you have log e and you have e. So those two are going to cancel out and you're just going to be left with k. So this and this are going to cancel out. So this and this are going to cancel out. Just going to be left with a k, right? So yeah. So I said log e is ln. So it's ln 1 comma 3 is equal to these two cancel out. So I'm just left with a k. So that's what my k is. So I can write that down. Ln 1 comma 3, right? Plus my c. That should be your answer. Okay, that brings us to the end of today's session. I really hope it helped to clarify any of your confusions. Please kindly note that I will be hosting an integration boot camp on the 13th of April. Poster will be distributed to the groups, right, to let you guys know. And just to remind you guys, the boot camp is 280 rands and it's for 4 hours. The bootcamp is online, hence it is 4 hours. Normally our bootcamps are 3 hours, 3 hour and a half hours, right? But this one is going to be 4 hours to make up for the fact that it's online. We're not able to secure a venue, so we couldn't have an in-person bootcamp. But for the next bootcamps, I'll really try to secure a venue on time. So thank you so much, and shout out to everybody who signed up for the boot camps that we had. Hence we're able to buy this tablet that has a stylus. So thank you so much to everyone who's been supporting Class of Asymptotes. I'm really humbled by your support and your love. Don't forget to subscribe. Make sure you click that subscribe button. Bye.